Hey guys, so this is CERN's website. I try to check it as much as I can just to stay on top of things. I mean, obviously I don't do so well, but here's their they finished the proton run. So the Large Hadron Collider is no longer running protons, which is its main. It can accelerate other things, but its main accelerate the thing that it accelerates most is protons. It's been accelerating protons all summer. It doesn't. It's gonna run for 4 weeks again in the fall, but it doesn't run in the winter because of electricity costs are too high. Anyway, they got a huge amount of data. They got almost 6 inverse femtobarns, which is like a unit of area, um, which is like the area of the collisions. Anyway, see somewhere they actually have their full the actual amount of collisions. Yeah, almost 6 inverse femtobarns. 4 million, 4 million higher. I was being stupid right here. 400 trillion. Sorry you guys have to hear that, but that's what you get without editing. I'm working on getting a new computer so I can edit, but Windows Movie Maker doesn't do HD. 400 trillion proton-proton collisions. That's huge. They were expecting 1 inverse femtobarn. They got almost 6. But they have pushed the standard model to its limits at high energies in the tera electron volt scale. But they really confirmed a lot of standard model stuff. So far, the standard model, they said, has passed with flying colors somewhere, they said. So that is very good, very great for the standard model, which my personal opinion is, yeah, it's true. I advocate the standard model, I guess you could say. So, but to actually get a full grip, we have excluded most of the mass range of the Higgs boson, except for a part at the smaller end. There is some gaps in between, up near the top, but for most of the part, most of the mass range is at the smaller end, which happens to be the more difficult end to study. So it looks like the Higgs boson is going to take a while to be found. Now, they have to get the full data set from this year analyzed in the next couple of weeks before they switch over to lead ions. And but that if to get the Higgs boson or new physics, they're going to need the full 10 inverse femtobarns that they initially foresaw. But if they can get almost 6 inverse femtobarns this year, they can probably get almost 8 or 9 inverse femtobarns next year. So that's going to far surpass their 10. It's going to be almost 18 or 19. So that's huge. They got lots of data, and I'm sure when the results start coming in more, you might see a lot of stuff on this Higgs boson over here. Probably no discoveries or anything, but we might get 2 sigma or 3 sigma, events or more exclusion of the mass range. But anyway, what they're going to do is they're going to they're now switching over to lead ions, 4 weeks. 4 weeks of lead ion running. And they, those lead ions, what they're trying to do is to do the studies on this quark gluon plasma, which is what they think that the early universe is formed of. Now, they've already done this last lead ion run, but they really, now running at these huge collision rates, they can really get more data on the for the lead ions with the Alice detector. And they're also going to attempt this year to see if the LHC is possible to use protons to probe the internal structure of the lead ions by smashing protons into lead ions. So you can think of taking something apart, see how it works. Except they're taking something apart with a proton going 99.9996 or something like that % of the speed of light. So, and obviously they're both going to be moving, like they're both going to hit each other moving at, super fast. So it's not like, they're going to hit protons into static lead ions. They're going to, one direction of the Large Hadron Collider is going to be protons, the other is going to be lead ions, and they hit each other, and they're going to see the ingredients of lead ions to a more defined and a smaller scale so that you can fully more understand the quark gluon plasma when they start creating it in the Alice detector later this year. So thanks for watching, and I'm really, excited to see the results come in, which I'm sure they will be pouring in a lot. Lots of conferences, lots of, CNN saying, oh, we found Higgs boson, the large hadron cauliflower, and all sorts of mispronouncing stuff, and say, well, this means that the Einstein is wrong if the large had, there's going to be a lot of that. There's going to be a lot of, like, we found it for 1 sigma event, even though it's just 1 sigma, what are you going to do with a 1 sigma event? That's nothing. But anyways, thanks for watching. 4 million higher. They've done almost 400 trillion proton-proton collisions. 400 trillion! Almost 6 inverse femtobarns. That is a ton. So I can't wait to get the lead-ion proton section running for a couple. It's only going to do that for a couple of days, but it should give them some neat results. If not, it'll at least prove it's capable of doing that and prove that they could actually get some results from it next year. And then the lead-ion run should be neat for the glow and plasma, which is already successfully done, so we're going to get some really additions onto that. And looking for the data. So, thanks. Bye.